In this section, we will be covering simplifying rational expressions. So section 7.2, simplifying rational expressions. Let's recall let's say 15 over 50. If I have that as a fraction, well, I can divide both the numerator and denominator by 5 and rewrite this rational number as an equivalent rational number, 3 over 10. We can do the exact same thing with rational expressions. So let's do an example on page 263. Let me do problem number 2. 16 over 22. In exercises 1 through 28, write the rational expression in lowest terms. So let's do this. So I can divide both the numerator and denominator by 2. And so I can simplify this to 8 over 11. Well, if this also involves variables, we can do the exact same thing. So suppose I have 3x plus 15 over 27. Let me first factor the numerator. So I can factor, there's a 3 in common. So what remains is 3 times the quantity x plus 5 over 27. I can divide both the numerator and denominator by 3. And so you get x plus 5 over 9. And I've simplified that rational expression to lowest terms. Let me do problem number 24. 3x minus 6 over x squared minus 4x plus 4. And so let me factor the numerator. So I have a 3 in common. What remains is x minus 2. For the denominator, well, it's a perfect square trinomial. So it just factors into x minus 2 over x minus 2. The x minus 2's cancel. So I get 3 over x minus 2. Let me do problem number 28. X squared minus x minus 2 over x squared minus 4x plus 4. Okay, so let's factor this. Well, the numerator factors into, this is a monic polynomial. So I'll bring down the minus times minus is plus. I want two whole numbers whose product is 2 and whose difference is 1. So 2 and 1. Again, this is a perfect square trinomial. And so it factors into, well, x minus 2 times x minus 2. I can cancel the x minus 2's. So what remains is x plus 1 over x minus 2. Let me do problem number 32. In exercises 29 through 68, simplify the rational expression. So basically the same thing that we've done. 2x plus 2 over 2x squared plus x minus 1. I can factor the numerator. What's in common is 2. What remains is x plus 1. I can factor the denominator. Well, this is not monic, but it factors easily into 2x minus 1 times x plus 1. the x plus 1's cancel. And so we have 2 over 2x minus 1. Let me do problem number 44. And so I have x cubed minus 8 over x squared plus 2x plus 4. Well, again, this is a special product formula. And so I can factor this into the numerator, into x minus 2 times x squared plus 2x plus 4. And while the denominator is the same thing, x squared plus 2x plus 4. And so I can cancel the x squares plus 2x plus 4s. And so you just get x minus 2. And you're done. Let me do problem number 60. And so I have 2x squared minus x minus 10 over 2x squared minus 11x plus 15. Let me factor. Well, the numerator factors into 2x minus 5 times x plus 2. The denominator factors into 2x minus 5 times x minus 3. So I can cancel the 2x minus 5's. And so you get x plus 2 over x minus 3. Let me do problem number 64. X squared minus 3x plus 2 over x squared minus 4x plus 3. Well, each of these are monic polynomials, so they're fairly easy to factor. So let me just put down x. I have got a minus times plus is minus, so these are both minuses. I want two whole numbers whose product is 2 and whose sum is 3. 2, 1. The denominator is also a monic polynomial, so I can factor it easily. Negative times positive negative, so again it's two negatives. I want the product of, I want two whole numbers whose product is 3 and whose sum is 4. So 3 and 1. So the x minus 1's cancel. And so you get x minus 2 over x minus 3. Let me do problem number 68. Z squared plus 7z minus 8 over z squared plus 6z minus 7. So let's factor this. Again, this is a monic polynomial, both for the numerator and denominator. And so, let me factor this. I have a plus times minus is minus. So bring down the plus, minus. I have a plus, I'll bring down the plus, times minus is minus. I want two whole numbers whose product is 8 and whose difference is 7, 8, 1. I want two whole numbers whose product is 7, whose difference is 6, 7 and 1. I can cancel the z minus 1's. And so you get z plus 8 over z plus 7. And that's your answer. And so that really finishes off this section. So you can do a group work for it. The name is section 7.2, and the password is simplify rationals. And so do this by Sunday, March 20 at 9 p.m.